Okay, we're going to be looking at the notes for section 13.2, graphing linear equations in Math 31. And our goal here is pretty simple. This is not much different than the last section. We're going to be using a table of values at the start here. And they're going to give us an equation. You can see that they give us the equation x minus y equals 4 to start out with, okay? So we're going to first of all plug in an x value of -1, and then we'll plug in an x value of 0, and we'll plug in a y value of 2, and then solve for the other variable. We'll plot those points and then pull out our ruler and make a nice little line out of this thing. If it's right, it should fall into a straight line. Okay. So the first calculations are when we have an x equal -1. And you can see that we've added 1 to both sides to get this 5. And then we divide both sides by -1 to get the y by itself, and that gives us a -5 value for the y. So 1 to the left and 5 down. There's our first point. Okay, the next calculations, we're going to use 0 for x. You can see that right there, and that's often a very convenient one to use. You'll see why in a minute. But when you put 0 in for x, the x just disappears, and you get the opposite of y equals 4, which you solve by dividing both sides by -1. So we end up with a -4 for the y value. 0, -4 is right here. Okay, we have one calculation left to fill in this chart. We're going to use a 2, but this time the 2 is on the y value side. So we have to say y equals 2. And plugging that into the equation, you can see that I put a 2 in where they used to say y up there. And after you put that 2 in and add it to both sides, you're going to get x equals 6. So 6, 2 is our next point. And sure enough, these things line up pretty well here. And so I'll pull out my little ruler drawing tool and draw a line right through there. Hopefully I hit these pretty well here. And you finish it off by indicating that the line continues in the same direction forever by putting the arrowheads on the end. Okay, we'll move on. We'll do, I'm going to do 3 or 4 examples here, and then I'll pick up on the next video. Okay, we have a new equation. Y is equal to -3 times the x value. So we're going to fill this chart in, and they're going to give us a y to start with. So we'll take care of that one in a minute. And then the next 2 ones, they give us x values. So we'll start with y equals 6. And you can see that when you put a 6 in for the y right here, when you put a 6 in for the y and divide both sides by -3, you get a -2 value for x. So that one's 2 to the left and 6 up. Okay, for the next calculation, we're going to use a 0 for the x, so we're going to put a 0 right there. And those calculations are shown here, and you get a 0 for the y. So this one, 0, 0, is just the origin. That point is on our graph. And we have one more to do. We're going to use a 3 for the x. So you can see on this calculations, I've put a 3 where it used to say x, and that gives us a y value of -9. So we'll plot that point, -3, -9. +3, -9 would be right there. And these are lining up pretty well. You have to excuse me while I reposition this line here. There. A little hard to do on my program that I'm using to indicate or show you this stuff here. Okay, so there's the equation y equals -3x. It's got a downhill slope to it, really steep. Okay, we'll do 2 more equations here on this short video, and then I'll move on to another one to finish out the notes. All right, let's see, what do we have here? Okay, y equals -3/4 times x plus 6. Now I'm going to point out something here. The x values that are chosen for us, they're convenient because they all divide by 4. You can see -8, if you plug it in, it divides by 4. 0, you can divide that easily by 4, you just get 0. And even 4 divides by 4. You could actually pick in other x values, but these 3 that are chosen are going to make our life a little easier because they divide by 4. So the first x value is -8. And if we plug in -8, you can see that you end up with 12 for the y. I'll come back and plot that in a minute, but let me first of all explain how I get this. -8 divided by 4 is -2. -2 times -3 is the 6. And then just add 6 more to it. And you end up with the 12. Okay, so now I got to plot this thing. It's 8 back and 12 up, which is actually a little bit off the charts here, but we can kind of shoot for it. It's about right there. And if it gets too far off, don't bother. Just don't even plot it. Okay, the next one we're going to do is 0 for the x. And that's convenient because this whole top front part here just disappears. 0 times any number, including -3/4, just gives 0. So 0 plus 6 ends up with 6. 0, 6. That would be right up here on the y-axis. Okay, now let's put 4 in. And I've got those calculations ready to show you. In this case, the the 4's cancel. And you get -3 plus 6 would be 3. So we're going to go ahead and plot the point 4, 3, which is right here. And you can see everything's lining up pretty well this time. So I'm going to take that right through there. And once I've done that, I'm going to indicate that it keeps going forever by putting those arrowheads on there. All right, now example 4 here is actually related to example 3. It says, show that 4x or 3x plus 4y equals 24 is the same equation as the one we just did in example 3. And you do that by solving for y. So let's start out with 3x plus 4y equals 24. And we're going to subtract 3x from both sides. It's as if it goes over to the other side and changes signs. So this is what we end up after that step is done. And then one more step to get to y by itself. We have to divide both sides by 4. And you can see that we end up with y equals -3/4 x. And in the back half, 24 divided by 4 would be plus 6. So this is the same as example 3. Okay, that's as much. I'm going to go one more here. I'm going to solve this one. And in this case, they don't give us any x's or any y's. So we're just going to pick x values. And we're going to pick convenient ones. But before we do that, we're going to solve for y like we just did on the previous example. Take the 2x over to the other side. And divide by -3. And that takes us down to an easier version to work with. You get 2/3, it's going to be positive, 2/3 x. Negative over negative is positive, and then 12 divided by -3 is -4. Okay, now what we're going to do in this case is we're going to pick numbers that divide by 3. So I'm going to arbitrarily say, let's go with -6. 0, and 9. Yeah, let's use 9. Okay, so let's put in -6 to start with. 6 equals 2/3 times -6 minus 4. Okay, this part of it here would be -2. And -2 times 2 is -4. Take away 4 is -8. So we need to go 6 back and 8 down. All right, the next one we're going to plug in is 0. That's a very convenient one. 2/3 times 0 minus 4. And in this case, this whole front part disappears because 0 times 2/3 is just 2/3. I'm sorry, it's just 0. And 0 minus 4 would give -4. So it hits at 0, -4. And the last one here we're going to plug in is 9. Oops. 2/3 times 9 minus 4. Okay, the first part here is going to give 3. 9 divided by 3 is 3. 3 times 2 is 6. So it's going to be 6 minus 4, which would be 2. So 9, 2 is the last one, and those lined up really well. If they don't line up, you know you've messed up. So let me draw my line, and then I have to reposition it here. Okay. And that takes us through the first 2 pages of your notes for section 13.2, and we'll pick up on the other side